Mars. The very name evokes images of a desolate wasteland, a barren and lonely planet that has captured the imagination of humanity for centuries. A cold and unforgiving world of rusty red dust and towering volcanoes, Mars stands as a stark contrast to the vibrant blue and green of Earth. Today, Mars is a planet of extremes. Its environment is one of the harshest in our solar system, with conditions that challenge even the most advanced technology. Its thin atmosphere offers little protection from the harsh radiation of space, leaving the surface exposed to the relentless bombardment of cosmic rays and solar winds. Temperatures swing wildly, plummeting to bone-chilling lows at night and barely rising above freezing during the day. The Martian day, or sol, is just over 24 hours, but the temperature variations are far more extreme than anything experienced on Earth. The Martian surface, scarred by ancient impacts and carved by colossal canyons, tells a story of a planet that has endured countless cataclysmic events. These scars are a testament to a turbulent past, a history written in the very rocks and dust that cover the planet. The landscape is a chaotic mix of towering mountains, deep valleys, and vast plains, all shaped by the forces of nature over billions of years. It stands as a testament to a turbulent past, a world that has been shaped and reshaped by the forces of nature. This is Mars as we know it now, a harsh and unforgiving world seemingly inhospitable to life. The environment is so extreme that it seems impossible for any form of life to survive, let alone thrive. But what if this image of Mars, this desolate portrait, is merely a snapshot in time? What if the Mars we see today is just one chapter in a much larger story? What if, beneath the desolate facade, lies the story of a planet that was once very different? A planet that may have had conditions suitable for life. A planet that may have been more Earth-like than we ever imagined. Recent discoveries have begun to paint a startlingly different picture of Mars. A picture that hints at a warmer, wetter, and potentially life-supporting past. Scientists have found evidence of ancient riverbeds, lakes, and even oceans that suggest Mars once had a climate that could support liquid water. These discoveries have opened up new possibilities for understanding the history of Mars and its potential to support life. They hint at a time when Mars may have been a very different place, a place where life could have existed. As we continue to explore and study this enigmatic planet, we may one day uncover the secrets of its past and unlock the mysteries of its desolate present. For decades, scientists have been intrigued by tantalizing clues scattered across the Martian surface. These clues, like whispers from a bygone era, point to a time when liquid water flowed freely across the planet. Vast canyons, dwarfing even the grandest on Earth, seem carved by ancient rivers. Dried-up lakebeds, etched with the telltale marks of long-gone shorelines, dot the Martian landscape. And then there's the ice. Locked away at the poles and buried beneath the surface, vast quantities of water ice tell a story of a planet that once held the key ingredient for life as we know it. These features, remnants of a bygone era, are more than just geological curiosities. They are pieces of a puzzle, clues that point to a time when Mars may have possessed all the necessary ingredients for life to emerge. The search for life beyond Earth is, at its core, a search for water. Water is the most fundamental requirement for life as we know it. Without water, the complex biochemical processes that sustain life simply cannot occur. This is why scientists have long focused their efforts on finding water when exploring other planets and moons in our solar system. Water is essential for all known life. It is the medium in which life's chemical reactions take place. On Earth, water is involved in everything from the metabolism of cells to the regulation of temperature. It is the solvent that allows nutrients to be transported within organisms and waste products to be expelled. It acts as a solvent, a transport medium, and a key participant in countless biological reactions. The presence of water on another planet would suggest that similar processes could potentially occur there, making it a prime target in the search for extraterrestrial life. The discovery of evidence for past liquid water on Mars was a watershed moment, fueling speculation that the red planet may have once harbored life. Ancient river valleys, lake beds, and mineral deposits all point to a time when Mars was much wetter and potentially habitable. But water alone is not enough. While the presence of water is a crucial piece of the puzzle, it is not the only requirement for life. Life as we know it also needs a source of energy, a stable environment, and a variety of chemical elements and compounds. Life as we know it requires a complex cocktail of ingredients, including organic molecules, the building blocks of life. These molecules, which include amino acids, nucleotides, and lipids, are the raw materials from which proteins, DNA, and cell membranes are constructed. In recent years, robotic explorers like the Curiosity rover have made groundbreaking discoveries detecting organic molecules preserved in Martian rocks. These findings suggest that the basic ingredients for life were present on Mars in the past. These molecules, while not direct evidence of life itself, are the raw materials from which life is built. Their presence indicates that the chemical processes necessary for life could have occurred on Mars. Their presence on Mars adds another layer of intrigue to the story of this enigmatic planet. It raises the possibility that Mars was once a more Earth-like world with conditions suitable for life. The evidence, though still circumstantial, is mounting. Each new discovery adds to our understanding of Mars's past and its potential to support life. It suggests that ancient Mars may have possessed all the necessary ingredients for life to arise. If life did emerge on Mars, it would have had to adapt to the planet's changing conditions over time. But if life did exist on Mars, what happened to it? Did it perish as the planet's climate changed? Or did it find a way to survive in the harsh conditions that followed? And what can the fate of the red planet teach us about the fragility of habitable worlds? Mars serves as a stark reminder of how quickly a planet's environment can change. Understanding what happened to Mars could help us protect our own planet and ensure that it remains habitable for future generations. Section 4. The Great Martian Drying. Mars, the fourth planet from the Sun, has long fascinated scientists and dreamers alike. Its striking red surface and mysterious features have led to countless theories and explorations. But one of the most intriguing aspects of Mars is its dramatic transformation over billions of years. The evidence suggests that Mars wasn't always a desolate wasteland. Ancient riverbeds, lake basins, and mineral deposits indicate that liquid water once flowed on its surface. So, what happened to this once potentially vibrant planet? Why did Mars, once potentially teeming with the potential for life, transform into the arid world we see today? The answer lies in a combination of factors that work together to strip Mars of its life-sustaining properties. Scientists believe that a dramatic shift in Mars's climate is responsible for the planet's transformation. This shift was not a sudden event but a gradual process that took place over millions of years. Unlike Earth, with its protective magnetic field, Mars is exposed to the full brunt of the sun's radiation and the onslaught of solar wind. This lack of a magnetic shield left Mars vulnerable to the harsh conditions of space. Over billions of years, the sun's relentless energy stripped away Mars's once thicker atmosphere. This process, known as atmospheric sputtering, gradually eroded the planet's ability to retain heat and water. This atmospheric loss had a catastrophic effect on the Martian climate. Without a thick atmosphere to trap heat, temperatures on Mars began to plummet, making it increasingly difficult for liquid water to exist. Temperatures plummeted and liquid water, once flowing freely, froze or evaporated into space. The once warm and wet environment became cold and dry, leading to the desolate landscape we see today. The planet that may have once held such promise for life was transformed into the cold, dry world we observe today. The loss of water and the harsh climate made it nearly impossible for life as we know it to survive. The story of Mars is a cautionary tale, a reminder of the delicate balance that sustains habitable environments. It shows us how vulnerable planets can be to changes in their climate and atmosphere. It underscores the importance of understanding the factors that can drive planetary climate change. By studying Mars, we can learn valuable lessons about the potential future of our own planet and the steps we need to take to protect it. Scientists continue to study Mars's past to gain insights into Earth's future. The red planet serves as a natural laboratory, helping us understand the processes that can lead to dramatic climate shifts. Missions to Mars, such as the rovers and orbiters, have provided a wealth of data that has deepened our understanding of planetary climates. These missions have revealed the complex history of Mars and its transformation over time. Discoveries of ancient water sources on Mars have been particularly significant. They suggest that Mars may have once had conditions suitable for life, raising questions about the planet's potential to harbor life in the past. The implications of Mars's climate change extend beyond the red planet. They remind us of the importance of protecting our own atmosphere and climate to ensure the continued habitability of Earth. Future exploration of Mars will continue to focus on understanding its climate history and searching for signs of past or present life. These efforts will not only expand our knowledge of Mars, but also provide valuable insights into the broader question of life's existence in the universe. Mars stands as a symbol of both planetary resilience and fragility. Its story is a testament to the dynamic and ever-changing nature of planets, and a reminder of the need to cherish and protect our own world. Section 5. A paradigm shift for space exploration. The discovery that Mars may have once been habitable has sent shockwaves through the scientific community and beyond. It has reignited our fascination with the red planet, transforming it from a distant, desolate world into a potential cradle of ancient life. This newfound understanding has profound implications for future space exploration missions. It focuses our attention on the search for signs of past life on Mars, a quest that could revolutionize our understanding of our place in the cosmos. No longer are we simply exploring Mars out of scientific curiosity. We are now searching for answers to some of humanity's most profound questions. Are we alone in the universe? Did life ever exist on other planets? The answers to these questions, if they exist, may very well lie buried beneath the red dust of Mars.